started EME in 1993, but he took a break in the early 2000s until 2022 and got back on EME again. He's currently QRB on 70 and 23 centimeters. Carson has been developing software and hardware professionally for 42 plus years, and he started with electronics at the age of 7. That's a good start. He's developed several projects, devices, and software applications for ham radio, particularly EME use. Among these are things for remote operation and control of PA systems, power monitoring, QRO hybrids, rotor control, and various software applications. Most of these have been made publicly available for others to use and build. Please welcome Carson.
Yeah, thank you very much, and good morning. I'm going to give a talk today on how I did EME, the second round I was on, as Barry mentioned, some years ago. This time I decided to do it a bit different, and yeah, hence the title of the presentation, EME the Hard Way. I know that for new EMEers that can be a bit misleading. So there's a warning. This is absolutely not what is required to get on EME. In fact, I would not even encourage it. There are many other ways of doing it. One of them is the excellent station by Robert, a dear friend in Germany, which is using a cooker dish, surprise. And he has a very efficient system. It doesn't take up much space, and he is extremely successful. The agenda mostly divided in two parts: the dish system, and then all the components that went into the dish systems, which is probably the boring part, but all details are here, and it is available as a PDF afterwards, so you can dive into it. So some of the slides I will go over pretty quickly, and some I will get a little bit further into. The history, just short: born 66, married to Henriette on the front row. We have 2 boys, 3 grandkids, and 2 cats. I work as a software and hardware developer, and have been doing so for forever. Got my license in '92, started on satellite at HF the same year. Got on 2-meter EME with 4 Yagis and a kilowatt with 3 tubes in a PA, as a PA should be, in '93. And I built my first dish in 1994, dual water-cooled 2C39s, which I bet a lot of you know and have heard the sound when they go poof. So that was a lot of fun. We moved the QGH in '95, and I started building 8 15-element cross Yagis for 2-meter. But I gave up on that. I got help from a massive storm and some heavy QRM, so I abandoned 2-meter at that time. I built an 8-meter dish for 23 cents in 2000, and in 2003 I stopped being a ham. Work and life in general got in the way, and then I had been doing other stuff and hobbies and so on. But in 22 I could not stay away any longer. So probably more in here that has tried the same. So I got back on satellites because that was what I did the first time. I made 9,000 plus QSO in 2.5 years. Worked a lot of countries and WAS and so on. And that was the whole idea all the way was to get back on EME. So I rebuilt my satellite antennas in 24, so 4 times 23 element horizontal Yagis for 70 cents. And that was just to get a quick fix to get back on EME as quick as possible. And also because I've never been on 70 centimeter EME, so it was a logical choice. And then at the same time I started designing my dish system, 4.8-meter dish, and all the components that went into it. Now I could have taken the easy road and got something already done and assembled a system from But I instead chose to do it the hard way and design as much of the system myself as I could with my knowledge or lack of. And then most importantly, I wanted it to share it with others, so that my hope was that maybe some new guy or old guy could use one or two of the components I have developed and thereby improving their own station or make it easier for them to get going. I started the installation in the summer last year, and it was a lot of work. This is my old system, just a quick, my 4x15 elements back in '93, 1 year after I got my license, and my 8 cross yagis in '97, which was destroyed by storm and QRM. And my first dish, 5 meter, which is now at WSJT-x Hans, so some of you have probably worked him. And my 8 meter this year, that was when I stopped being a ham. It is now located at the SM7 GBF in Sweden. I think he extended it to a 10 meter. One note about the presentation here, all the links here, underlined, so on, are working, so they point to the right places on the website and so on. So you'll see that later. This is my 23 or 70 centimeter EME system, small, very small system, and it's been working since 24, whenever Faraday allows it. Yeah, this is the system. I'm not fond of ladders, or my wife is not fond of that I'm on a ladder, and so everything can fold down and can be reached from ground level. Yeah, this is just PA system is remote on the 70 cents. It sits on the tower and is fully remotely controlled. One of the smaller stations I work on 70 is D0JDL John, with 2 14 elements on a tripod in his backyard, using a tube as a pointing device and a mobile phone. And we worked. The first time we worked, we thought it was log, so we continued, and we have now worked 14 times, and it can't be log anymore. And the signal reports are pretty good also, we think. So this was only to get my my EME fever lowered a bit while I was doing the project with the dish. And this time I decided to make a smaller dish than the first 2 I had. I'm getting older, and in our current QDH, it sits in the back of the house in the garden, and I can't get any machines in there, so everything has to be done with 60-year-old hands. I developed most of the subsystem, and as I said, make most of these available for others to build, except the dish. I got that as a kit from Senec OK1 Delta Fox Charlie, and he makes different kits of dish from, I think, 1.5, 1.8 meters and up to 4.8. Luckily, he didn't do any 6 meters, because I would probably have one of them instead, and regretted it like that. The whole project was an excellent exercise. There's a lot of things going on, electronic software, RF, mechanical design. I started with mechanical design 3 years ago. Couldn't draw a line in the CAD system at that time, but I got pretty well to that. Everything is done in CAD, and when I say everything, I mean everything. You can see an example of it here. If you zoom into the system, this is the 23 centimeter PA mounted on the elevation boom. If you zoom into this little box, which is my remote PA control and monitoring system, and this one of my dual RF head that measures forward and reflected power, and you take off the lid, you see the SMD components on the PCBs. So that is the level of detail that went into it. And although it might seem as a lot of work, which it is, it's also easy to spot crazy stuff that you only spot when you stand on the ladder and try to fasten a screw somewhere where it doesn't fit, because everything here was tested and everything was checked in CAD. Below is the 90-degree DJ9BV hybrid for the two PA blocks, and if you remove the lid of that, you see the strip line, which is the strip line that has actually been produced for it. So it's completely 100% real life. The dish system is made on a foldable tower. It can fold over the winch. Again, even though the rotation point is only 2.6 meters above the ground, I don't like ladders and no machine, so I had to be able to assemble everything on ground level. And everything for this system is also available on the web page. I know of one guy that is building this, copying it completely. The 70 centimeter system you saw before, I know that there are 5 guys who have copied that and using it. If others have or not, I don't know, but at least some found it useful. And everything is available except for the dish, because I can't publish somebody else's work, of course. But the dish is very, not cheap, that's negative, but affordable from Cemex, so that's possible. Some pictures from the building process. I use a slew drive, the SVH7 from Corson in China, which is a heavy beast, 85 kilograms or 180 pounds or something. The total system is a little bit more than half a ton. You see the winch here and the tilting point here and so on. You see some more pictures afterwards. The assembly, as I said, had to be handled by 2 60-year-old hands, so it was a mix of ladders and pulleys and stuff like that to get it all assembled. This is from the first few stages, mounting steel for elevation and so on. The slew drive has infinite power. At least it has if your arm comes in its path. It's incredibly strong. So, and as you'll see in a moment, I also did the rotor. So I thought it was best to make an end stop device with magnetic switches. This is also available on the web page. You can build your own, and you can download everything from the web. It uses 4 magnetic switches and will disable the engines if you pass it. It has an override key also, so you can drive it past the end switch if you absolutely need. Yeah, this is a few pictures from the building process, elevation, mechanics, starting to attach the ribs. The kit from Cemex is absolutely perfect. Everything fits, everything is laser cut, and it's just a joy. It's just like assembling a kit of Lego bricks. Goes together perfect. Everything is mounted around a central galvanized steel tube going through the top and bottom hub. Ribs are connected using a lot of M5 screws. And the central tube made this possible so that, again, I could stand on the ground and do everything, and yeah, you can even turn it with one finger. So it was a joy to assemble the stuff. And here you have it in a semi-finished state, and that leads me to the worst thing in building a dish. I think most of you will agree. The mesh, which can be a mess. The other 2 dishes I made the error of attaching full strips of meshing across the dish, and when you do that, you have to have it to fold in 2 dimensions. that's not something mesh likes to do. So this time, instead, I decided the right way to cut it out in pie-shaped pieces. I made a template in CAD, and then I could cut 3 layers of mesh at one time with an angle grinder. It took me 1.5 hours to cut 16 pieces of mesh, and it was a joy. It was so easy. But just be careful, because where you cut it with an angle grinder, you have small knives sticking out. So wash your hands. Attachment on the rings and the ribs, we're using 0.8 millimeter galvanized or stainless steel wire, and using safety pliers to spin it. I have around 800 pieces of wire to connect it to the structure. And this was much more easy than I had ever thought when doing it like this. It was just a joy. It also helped, of course, that the sun was shining and everything could be done from ground level. This is missing 3 pieces, and this is also something I bet some of you knows. I think I still have the scars to prove it. Cable routing. There are many ways of doing that, and I tried and simulated all kinds of way of getting the wires to the dish in an efficient way, and also at the same time looking wife friendly. It should look okay. So I used a flexible hose which is lined with the steel spiral inside, a 60 millimeter diameter, and using that and some 3D printed stuff, I came up with a solution that, until now at least, works perfectly. It wraps around the tower when it rotates, and the cables, when it elevates, are just free enough up here to just lay down perfectly. That's the cable. There's nothing to that. PA systems for 23 and 70 centimeters are mounted on the elevation booms. I'm not on 70 yet on the dish. I need a feed. But right now I'm focusing on the 23 and getting that dialed in. And when everything runs according to plan there, I will start focusing on a 70 centimeter feed, because I want rotable polarization. I hate Faraday. So that's the coming project. This is the 23 centimeter PA, dual WC PPL and a hybrid combiner, measuring power output on the isolation port, measuring power output on the isolation port of the input hybrid, power distribution, current monitoring, you'll see that later on, and remote control and monitoring, and a lot of other stuff. The box weighs, I think, 35 kilograms, so there's a lot of stuff going on. The other side is the 70 centimeter PA, which is 4 modified DVD modules, and the combiners are also from DVD modules, and the 4 PAs and the 2 combiners, which gives out a solid 1 kilowatt on 70 centimeters, cost me the staggering amount of 180 euros in total. And then maybe 30 minutes of work to modify the PA modules. I got it off eBay, which still sells the modules. And I made a website for that with all the descriptions, how to modify the modules, what to be careful about, expected results, and so on. So yeah, you can see that there. I chose to mount the PAs on the elevation boom. The plus side is low cable loss and less clutter in the shack, which is not too big in my case, and no noise. But it's more complicated. You need remote control and operation, and you need to control humidity. But my repan module handles the negatives. You'll see that later on. I have on the PA blocks, I have heating elements, 25 watt on each module, so I can control that. I have a sensor in here, the small, you can probably see it, but there's a small RH sensor that gives input to the repan module. So if any of the temperature sensors in the PAs or whatever where I mount them gets too close of the dew point, the current dew point, it will fire up the heating elements and it will turn on the fans in there. So it will keep the temperature and the humidity down inside the PAs, and that seems to work. I use the same system on the 70 centimeter PA, and that has been working now for a couple of years without any problems. Yeah, some of the helping hands and paws in the process, my lovely wife Henriette, posing with the feed horn. We'll get back to that in a moment, and our two cats. There were actually also a picture of the hole with our robotic lawnmower laying down on its head below it. That's a long story, I won't bother you. And there it is in all its glory. This is only a couple of weeks old, just right after I made the first QSOs. And yes, behind here are a vineyard, and no, it's not our wine. It's we get to look at them, but somebody else does all the hard work. So that's it. So this was basically the result of these 2 years of work, getting a dish done and getting it operating. But getting there was really hard and a lot of work. And I compare it with a term called yak shaving. You're getting wool to sell at the market, to raise some money, to buy a ladder, to reach the roof, to fix the leak, to stop the drip, to save the books. It felt like that's the process, because I had always a line of things I need to do in order to do the next step. And the final step was to get a QSO. As I said, I decided from the start to develop everything, or at least most of it, the things I had the knowledge to do. And I spent around 2 years doing all the stuff you'll see here. I made a rotor controller. I could have bought one. There are many excellent systems out there, but no, I had to make my own. Made a mobile application so you could stand on a ladder at the dish and control it. I made the repan module so I could remote control and monitor PA systems. I made a lot of software. I made that available. I made a number of dual RF head. I call them. I wish I had found a more catchy name when I did it, but it describes what it is. It's an RF head that can measure two inputs, and I made different versions: analog output, USB, a standalone power meter, and an Ethernet connected one. You'll see that later on. I made a high power directional coupler based on the excellent note from Paul. WSJT-x, which is here somewhere, I think. I made high power hybrids for combining the PAs, and at the same time I also made some for 70 centimeters. It was actually Frank NC1I that asked me if I could do that. He had a design made for him, and I made that in CAD and so on, and all of that can also be downloaded, and you can produce your own if you want. Flatpack 2 from a Norwegian company that makes power supplies, Eltec. They make some really nice 3 kilowatt, 50 volts power supplies you can get on eBay. I made attenuators. Don't run a 400 watt attenuator at 650 watt on a too little heatsink. It goes bad. You'll see those later. Sequencer I had to do. I handed over the design to antenna amplifiers with Gordon. He could do whatever he wanted, and he wanted to put it into production. I said, go ahead, I don't care. So he produces those, and it can be bought from him now. The question I got asked a lot for many years is, how big should a heatsink be? Big enough is the most used answer, and I had myself and everybody I know have always, found some kind of heatsink at the junkyard, and this looks okay, and we will just mount it and see if it goes. And usually it goes, but I wanted to make something that was possible to just go and buy from, you know, an outlet, a Mouser or a GGT or whatever. So I made a website with the calculations and formulas and what you should be careful about when you select a fan, because a fan is not just a fan, it has to overcome the back pressure and so on. There's a website dedicated to that, and a downloadable docs, a 3D printed dock that will interface fans to the heating and so on. Yep. I needed a driver for the dual PAs, so I found a design for a 150 watt, really nice small PA, and with a cheap LD MOS. And I made hardware for that, cover heat spreader and a box and so on around it, which a lot of people, I think I've sent out more than 50 PCBs and 40 heat spreaders to people now. I did some mechanics, heat spreaders and boxes for the W6PQL 23cm modules, overcurrent protection switch, monitor, single dual quad channels, high power FETs that can switch off the power to the PA if something goes wrong, or before it goes wrong. I had, because of different issues, I had to make my own feed horn. A couple of companies promised me things they didn't manage to come through with. So I made my own feed horn based on Raster OM6 alpha design. And I made a few extra things along the path. Simple Calc, Skyscanner, and SatTrack. And actually a few more which are not mentioned here, but yeah, it's just small things. Everything is available on our webpage. You can download videos of how to use stuff, how to calibrate, yeah, all kinds of things on there, schematics and step files for the mechanics and so on. Just quickly over some of the projects. My rotor controller, as I said, it would have saved me a couple of hundred hours to buy one, but yeah, no. So we made our own, of course. It has a number of interfaces, touchscreen, and generally it's overbuilt because it was only supposed to be an internal project. So I didn't care about cost or how efficient it was to assemble and so on. But it seems that this will probably change in the coming year. It has an inbuilt web server, so you can access it from a browser. You can get all kinds of information, the current for the motors, the current sky temperature. Yeah. Which is not in any way as accurate as some of the things we saw yesterday, but it's based on the traditional method, which is probably not correct, but at least it gives you some sense of it, and it was functioning. It can track autonomously sun and moon, will show all kinds of information. You can do the usual park and track and whatever. You can also access it through a VNC client if you want that for remote operation. And I made a small mobile application so I could stand at the dish and do something. Yeah, that's it. The repan module for remote monitoring, basically it's an I/O system with Ethernet. It has a lot of, not a lot, but it has some digital inputs, analog inputs, relay outputs, CAN bus, one wire, and 2 PWM channels for fans. You can connect up to 8 temperature sensors. You can make triggers and alarms, which will work autonomously. So if you don't have to have a PC connected on the network or anything, just the system itself will just run everything. If you have a high SWR or high temperature or high current or something, the repan will automatically shut stuff down and it will report an error over the network. It controls also the humidity and the dew point is monitored. It calculates forward reflected SVR if you are connected to one of my dual RF fans and the analog inputs. You can connect up to 2 more analog dual RF heads. so you can monitor 4 extra power, RF power. And in my dual W6PQL on 23, that's used for measuring the isolation course on the hybrids. So they are monitored. If you get a PA that fails for some reason or something goes wrong, you will see a lot of power on the isolation port, and that is detected by the repan module, and everything is shut down. The video here is from the W6PQL. I have the application you see here comes in a single channel. This is a 70 centimeter system. This is a dual channel where you have left and right side current and temperatures. I also have a quad version for the 70 centimeter DBB set where you measure 4 current for drain currents. It will log to a comma separated file if you want, so you get a lot of statistics, calculates the dissipation, DC dissipation, all kinds of stuff. And the source code is available for that, so you can change it to whatever you want. And all the data coming out of the repan module is documented. It comes out on the socket connection, so you can use it in Node-RED or whatever program you would like to present the data from. Dual RF head. This is the analog version. You have 2 inputs and you have 2 analog outputs. You get a voltage that is proportional to the RF level in dB. And this one is around minus 55 millivolts per dB. And this means that at 0 or at no power, you will get approximately 4.4 volts or so. And then you will get increasingly a lower voltage when you raise the power. At minus 40 dBm, you get 3.8 volts, and at plus 5 dBm, you get 1.3 volts. And the step is minus 55.7 millivolts per dB. And you mount that on, for example, on a directional coupler, and out of that you get 2 analog voltages that is proportional to the forward and the reflected power. I made different versions because the first one worked very nicely, so I thought, let me do one with the USB output. So I have one that you just connect on the USB port. It shows up as a virtual serial port, FTDI chip, and it outputs the data it measures on as a ASCII string on the serial port about, I think, 20 times a second or so, 15, 20 times a second. And you get measured power in watt, dBm, and you get the calculated SWR, and you get it both for the average and for the peak power. And source code is of course freely available, and you can build your own PCB, and yeah, everything is available on the website. Most of the products or projects are, the files are there, as I said, and I also make limited batches of some of the products. So if you don't want to assemble them yourself or have the capabilities to do it, I have most of it as available. This is the one, and this is, again, the analog and the USB was successful, so I thought, let me do one that can do standalone. So I made 2, a big one and a small one. The big one is nice, the small one is not easy to navigate because at least my fingers are too big. But I thought the displays are made from M5 stack. Tab 5 is, and this one is Core S3. And my module, I made that so the external dimension was the same as the Core S3, so it fits on the back of it. So I had to do it because it was too neat. So I made a version for the Core S3. I don't know if anybody has built that one. I know a lot uses those, this big die here, but the small one I don't know. It also has limited battery time, only 1 hour or so on charge, and this one will go for, I don't know, 5 or 7 hours on charge. They measure the same, dBm, watt, average, peak, calculates SWR. The big one actually also can connect to a small relay module, so that if the SWR exceeds a certain limit, it will trigger the relay. And that's the third dual RF, and I kept going. So I made the fourth one which is the final one. Some people asked me if I had something that would work directly on Ethernet, and I said no, but now I say yes. I made the dual RF connects to Ethernet, 10/100 megabits. It measures, it has the same front end as the others, usable up to 10 gigahertz. And yeah, the max input is the same also plus TBM, 10 dBm. I recommend to keep it at maybe 0 to +5 to get the best linearity. It outputs everything over a socket. You can have multiple clients, and also I, shove the web server into it. And this is actually the web page for it. So you can just open a browser and you can look into the power meter directly. And the source code for this is of course also available. It is so that it actually uses the same software as the USB version, which can also connect to the standalone devices, because the PC program thinks this is a dual RF head USB, even though it's actually not, but the PC program don't know. And the same here is the same program that just listens for data from the network. Directional copper, as I said, built from Paul's extremely nice notes on directional coppers. And as I think some of you know, it's easy to make a directional copper. It's very hard to make a good directional copper. And I can attest to that. There's a lot of experiments going into this, getting the right design, getting a good directivity, return loss. And notice I have put those numbers in quotes because we know that you can't measure that. I can't, and I generally think that -30 or -35, everything below that is a lie, at least for human equipment. Some can, but I can certainly not. Works perfect on 270, 23, and 13 centimeters. Directivity is okay on 13, but it's very good on 23 centimeters, which was, to be honest, what I focused on at the time. It's in use for many different things. It handles a lot of power. It's running in a dual PQL amp on 2 meter here from an Austrian guy. And I know that on 23 it can easily handle 1.5 kilowatts without any problems. It has coupling of on 23 centimeters, -42 dBm. So usually you connect an SMA attenuator on the output. I think most normal is 20 dB, and then you will get around 0 dBm at 1 kilowatt through it, and that fits perfectly with my dual RF. I had to combine the PAs. I could have bought a hybrid, but no, I made one. I made that same hybrid back in 1995, I think, designed by Rainer Bartelsmeyer. He was actually visiting me that time and saw them, and he was impressed at that time, and they looked like, man, this one looks better. Let me put it that way, but it works. And I know that you can get hybrids to get a much better return loss if you really tweak it. I didn't care. I wanted something better than 20 dB, and I wanted something that was that you could copy and don't have to spend a week trimming and adjusting things. And I made a bunch of those, and others have also copied them with success. You can download everything and you can make your own. I made some low power ones for 23 and also 70 and 2 meters because I was asked about it. Using hybrids you can buy, which are very cheap, affordable. Again, everything is available, so you can just download and do it yourself. I should maybe pause here because I have a box of stuff. I'm not sure if I should. Yeah, maybe I should pass some of it around just to give you an idea talking about.
You want it back?
It depends. And pass it around, and it's just to give you a feeling. Sometimes it's nice to touch things. Yeah, so you can have a look. Yeah, and as I said, I needed to get some power to the PAs, and I was able to buy a bunch of these L-Tech power supplies on eBay, and again, I could buy an adapter board from somebody else, but yeah, the title of the presentation wouldn't be correct if I did. So I made my own. And that is also available. You can download, you can make your own PCBs, or you can get finished modules from me, whatever you like. It has all kinds of interfaces that is brought out. The CAN bus connection actually connects to the REPAM module I talked about. So you can, from the software for the REPAM, you can go and configure your power supply. You can set the maximum voltage, maximum current, and stuff like that, and you can monitor it. So all of that is also, of course, available. Attenuators, I had to monitor. I had a crappy dummy load from WeMo in Germany that was supposed to be doing 800 watts on 23, and it didn't. It was bad, so I had to make my own, at least to measure the power. But I also needed an attenuator that I could connect on the hybrids to monitor the isolation cord. So I made a 400 watts, which is working okay. Return loss is okay, I think, on 23, 13, and not so much. And as I said, don't put 650 watts into that one without a big enough heatsink. It will smell really bad. So I made a 1500 watt also with a 716 connector. Has a okay return loss, I think, 26 on 23 centimeters, and it has a coupling factor of minus 57 dB on 23. So I have a probe sitting here, and I connect this one to one of my dual RF heads, so I can monitor the power from it. And I actually used this setup for a long time to measure the output power of the PA. Just remember to mount a low-pass filter when you do that, because if you have a PA, you'll generate some harmonics, and as you see the return or the coupling on this one is 60 dB better on 13 than it is on 23, so the harmonics will get easier access to the coupling core. So put a low-pass filter on it. Otherwise, you would get an efficiency of 65% on the P2L, and that's a lot. Sequencer, I could have bought one. I didn't, and it happened so that Goran, Antennas Amplifier, asked me if I could design one for him at some point. I said I couldn't because I didn't have the time, and half a year later I needed one myself, so I designed it, and I asked him if he wanted it, and he wanted it. So I made all the electronics, the embedded software, and the PC applications for the configuration. And that one you can't download from my webpage, but you can buy it from Antennas Amplifiers. And I think a few in here already have done so. Heatsink, as I said, we pick whatever heatsink we can find at the junkyard, and I think it works. I did something that you can actually buy and order, and you can put the heat sinks on, and I made a 3D printable duct, which a lot have downloaded and printed themselves. And most importantly, the web page explains how I did the things, so you can maybe adapt it to your own project and get a feeling of what is needed for this. And I used it in all my PAs, and this is the data from my 70 centimeters. Dissipates 500 watts, and the temperature rises 25 degrees. And the calculation set at 25 degrees, so it fits perfect 23 centimeter driver. Well, driver, I call it a small PA, and I got some smoke for that because people said 150 watt is not small on 23, but okay. It's based on two guys from China. They made it public, DG0AUB, and I forgot his call sign anyway. It's in the notes, and it will do the boss I made 180 watts at 55% efficiency, which is good on 23, and it's a €19 LD MOS, and they are quite rugged. Runs on the project runs on, what is it, 28 volts DC, and 12 amps approximately, or 11.7, and has good gain and so on. I run one of those on 14 volts and use it as a driver for the dual PQL device. For that, I made a couple of heat spreaders and a box, a milled box. You can download all that from the web page. Until now, I have sent 50 PCBs out and more than 40 heat spreaders for this little guy. So a lot of people are building this, and some of those are being used on cooker dishes. And I know a VK guy who's combining 4 of these together. So yeah, it's really popular. Dual PQL, 23 cents. I made some mechanics, a milled box. I didn't like the idea of having the PA sitting, really free. I can imagine dropping a screwdriver or something in there, and yeah, you know what happens then, bad things. So I wanted a box around it, so I designed that. Heat spreader I also made, so that can also be downloaded from the website. Temperature sensors and so on I have on it. Again, everything is available on the website. And yeah, it was actually less complicated making the PAs than I had feared. It worked really nice. I have for the isolation port, which tells you how well matched the two sides are. At 1.3 kilowatt output, I have around, I think, 2.8 watts or 3.8 watts on the isolation port, so that's good. Especially since some of the reflected power also shows up on the isolation port. Current monitor switches that can protect your PAs is something that is, I don't need that because nothing happens, but yeah, trust me. At the same time, it also works as an on-off switch on the high voltage line. It has a monitoring output for the input power and the output power voltage scaled up to so you get 60 volts through it, you get 4 volt out on the monitoring. You get 50 millivolts per amp. You load it. You can adjust how many amps the PA is allowed to draw before the switch switches off, and everything interfaces to my replan module. It's just wonderful. So it makes a complete system. And again, you can make your own. Everything is on the website, so you can just copy it. As I said, feed horn. It's a sad story. I finished the dish installation last year in August. And then it just sat in birth bars position without a feed horn. Even the cables were there. And I was getting more and more frustrated. And I emailed back and forth with those who have promised me feed horns. And my wife got more and more, do something. And I said, well, give them a chance. They will come up with it. In December, I lost it. So I started designing my own version of the OM6 alpha feed, pushed heavily by my wife. One thing is that the main tube is not something you just go out and buy at the hardware store, so that was extruded in Austria by a company. I had to have 6 meters, so that was that gave me 8 feed horns. I built one for myself, and then I sent the rest 7 around to the world. I think Australia, Dubai, Norway, Italy, France. Yeah, so a lot of people got the kit. Everything is CNC machined, except the main tube. You only I say you just need to drill the mounting holes there, and as you see, they should line up. And I made a drill jig that is 3D printed, so it makes it a lot easier. But all the critical parts are CNC machined. So, for example, interfacing the TX and RX probe to 50 ohm is taken care of by a CNC machine. And this works really good, I think. I'm still experimenting. Right now I have mounted a chaparral choke on it and saw a small improvement, and I'm still fiddling a bit with the focus point, and I know that the feed horn is not pointed in the center of the dish. I could see it when I measured sun noise when the sun was drifting. I got some two peaks on both sides of the main lobe, and they were not equal. So I knew that something was not right. And I looked up to the dish, and I don't know why. I walked around that dish for a month with the feed horn, and I noticed that the feed was actually skewed. It was pointing to one side of the dish, and it was very obvious when I saw it. So when I get back from here, that's the next project, to get that right. Again, everything is available. You can build your own if you want, or maybe get some ideas how to do it or how not to do it. I also made some software applications. When I got back in 22, I needed something to track satellites and control my rotor and radio. There were a lot of programs available. I had to do my own. So I made a complete satellite tracking program that handles everything, and as I said, I made more than 9,000 QSO on that. Predicts satellites and so on, and the sun and moon. So they're also kind of satellites. I made a simple calc. We all know VK3UM's EME planner. Barry, how long do I have? Yeah, good, perfect. I'm almost done. So you can wake up now. VK3UM's EME planner, I used that back in the 90s, and it's a great program. It is very, very advanced and can do a lot of things. Unfortunately, the user interface is from the 90s, and it has, in my opinion, too many features for at least for beginners and for myself. There are things there I don't know what it's used for, and so I just end up putting it some arbitrary number in and think, oh, that's probably right. So I wanted something that was easy to understand, and also something that I could learn from how to do it. So I had a lot of input from various people, Peter D3LTF, one of them, and I managed to cook up something that gives the same results as VK3UM if you feed it with the same parameters on the input side. It will download solar flux data, and it will extrapolate that to the band you select. One thing that always gets to me is that when we quote the sun noise, I have 17 dB at the solar flux 140. Yeah, that's on 10.7 centimeters. What is it on 23 centimeters? Well, you can't just say one day 140 and the next day 140. The sun flux on 23 centimeters can be different. You can have a sun flux of 100 and on 120, and the one on the 100 actually has a higher number on 23. It all depends on how the various points are being measured. So I always quote the calculated or the interpolated SFU at the band you measure. It will do the usual stuff. It will predict the amount of sun noise you should measure. you can enter your data from losses and noise figures and so on, your gain and your the TA that you think your antenna sees, the noise. And you can do something called cross-check. It's a long explanation, but basically, if you enable that and you tell it what sun noise you measure, if all the other numbers are correct, and those we can pretty easily measure, losses and so on, then it will back calculate the TA that you have. So if you see maybe 1 dB less sun noise, it will calculate a new TA for you. Instead of 25K, it may be 35K. It can do the same for a terminator. If you switch this one on, it simulates that you connect an attenuator, or not an attenuator, a terminator on the LNA input. And on, for example, on 1296, I should be able to see, I think, 7.6 dB rise in noise from cold sky to the terminator. And if I only see, let's say I see 7.4 dB, I enter 7.4 dB, and it back calculates and tells me, well, your TA is actually 18 Kelvin instead. But it requires everything else is correct, otherwise you can't trust it. But it's another way of looking at things. It will also do the usual measuring, predicting echoes, both for yourself and your VA station. Sky scanner scans the sky for noise sources, it controls your rotor, measures the output from the radio and the audio, and it will make various sizes of sectors where it will measure. This is my 70 centimeter EME array, and this is where my house is. So guess where the noise comes from? Yeah. All of that is, of course, also available on the website. Not as source code, but you can download it for free. And Skyscanner can export in various ways, so you can use it on other places. This is Simple Calc. I use that for measuring sun noise. You have markers, reference markers and delta markers and so on. It will do all kinds of things. This is the terminator on the LNA. So this is also Simple Calc. It can do sun and moon sweep, where it will point to the sun or the moon. It will sweep with a defined area around the sun. In this case, 3 degrees azimuth and 3 degree elevation in 0.5 degree steps. And then it will create a data set like this, where it will normalize the data. The lowest signal will get 0, and then you have in dB what the feed is. And if you have your tracking correctly, you should see something like this, where you have an azimuth 0 offset and elevation 0 offset. You have a peak, like you see here. So that's an easy way of checking that your array is pointing correctly. So almost done. First results. March 22nd. I fastened the last screw and cable, which was big and a very special moment. And 40 minutes later, I did my first QSO 23 with an SSB QSO with Walter, went for BCB. Walter was one of the guys that was building the prototypes of the feed horn together with Rasto. And the next 5 hours, I was overwhelmed by calls. I did a lot of QSOs. And the week I had done 110, that was bankrupt in sending direct QSLs out. Got a few nice call signs in that period too. The small station is PA2B, 36 element, 200 watts, preamp and check, no elevation, some center down here. Got him minus 21, I think, both ways, and he was excited. And the next day he went out looking for a 3-meter dish. So it had a good effect on him. Sun noise is close to the predicted. It varies between 0 and minus 0.3 dB from the predicted. I'm still chasing. I'm not satisfied, and I have too much loss in front of the LNA. I'm focusing on that when the major things are away. I get my own echoes predicted at +5. I predicted 5.3, and I reached them at 5.3. I have minus 14.2 with around 6 or 8 watt at the feet. I'm not sure how much it is because it's the calibration is not perfect at that. And I have SSB echoes, and I think they are solid, but you can be the judge.
Hello Moon, hello Moon. Hello Tenerife. Thanks for listening. 7 trees and good luck.
I know that they are not 20 dB over S9, but in EME, I think it's okay. And that's pretty much it. And before I go to the questions, I want to say thanks to Ingrid, which is not here, LB6 Bravo. He's done a lot of brainstorming with me, review and suggestions for this. And also many thanks to my very good friend Lars Robert, who is not a hand, but he is as nutty as I am with technology. So he has done a lot of help. And last but not least, thanks to Henriette, my wife, who is here on the front. Patient for 45 years and especially the last 2 years. So, any questions? If we have time.
Yeah, we'll hold off on the question, but thank you very much, Kirsten. Excellent.